All right. Hi, everybody. I'm Daniel. I'm a front-end engineer at Bayerischer Rundfunk. And yeah, today I talk about PostgraphQL. PostgraphQL is a way to create a relay-compatible GraphQL server, pretty similar to what we've seen before. So there's one thing you need to know. Like, not every GraphQL compatible server is a relay server. Every relay server is talking GraphQL, but your GraphQL server needs to implement some special protocols to be relay compliant. So relay, I suppose everybody at least had heard about it, is a front-end library from Facebook for using GraphQL with your React app. And yeah, so basically that's the story why the Shift key has become the most used key on my keyboard, because usually I was writing JavaScript, but then we started using PostgraphQL, and so I went back to writing a lot of SQL queries again. And so that's what I want to show you. But first of all, hey, this is a React meetup. Why are we talking so much about backends? What I want to tell you is the story of two teams I've worked in at Bayerischer Rundfunk and what we've learned from that. So usually we got this structure. We got our front-end engineers. I was part of the front-end engineering team. Then we got our back-end engineers, and then we got our site reliability engineering team. And basically these were like three different teams, and they working aside each other, but like there was not a big overlap between the teams. And like front-end engineers were like all hyped about React and GraphQL and wanted to use all these fancy new technologies from Facebook. Back-end engineers were mainly thinking about REST APIs, and site reliability engineers, and who they care about the deployment and stuff like this, didn't really care about what was going on between backend and frontend, because they just like want to see their Docker containers running. And so with this structure, we basically built all the projects we were working on. But like the front-end engineers always wanted to like have GraphQL, and so we requested from our backend engineers, so could you not only provide a REST API but also a GraphQL API? And so basically then like the two teams, the front-end engineering team and the back-end engineering team, didn't really know what the others was talking about. Like the front-end engineers were, we want GraphQL, and then later we need relay support, because then we in the front-end engineering team realized, okay, not every GraphQL server is compliant to relay. So then we said, okay, we need relay support now. And then we were asking, why is everything slow now? And the cursors are not working as expected, and you need to return edges and not nodes, and all like these crazy GraphQL specific things. And can we have this mutation and that mutation? And the backend has a bug. And then we realized, oh no, it's relay that has a bug, and we all blamed it to the backend engineers. And finally, the backend engineers were like reversed hand with middle finger extended emoji. Yeah, so that was the case, and it didn't really work out for us that way. But the good thing is we learned from that. And basically what we did on the next project is we didn't have like the 3 layers of teams, but we had this 3 layers of teams. So basically everybody was working on all parts of the system. So there weren't like front-end engineers, back-end engineers, and site reliability engineers anymore, but everybody was working on the whole stack. And the term cross-stack developer came up, like I heard it first at ReactConf 2016. So I didn't make it up. Somebody else did. I forgot who it was. But basically what it says like is the dev is working on all parts of the system. So a cross-stack developer is responsible for implementing React UI components, but also creates the GraphQL mutations, exactly the mutations he needs. And he also writes the database migrations he probably needs if he wants like to save new data in the database. And he also deploys the changes and cares about performance and can I deploy my stuff and does it scale, all of these questions. So what we saw is like people were way more thinking about, okay, what impact does a single feature have? Because before the front-end engineers were just like requesting new features and not really thinking about the impact it would have on the back end and so on. And so I really like this idea that everybody had ownership over the whole application. And yeah, another thing we introduced is a so-called monorepo. Monorepos is like, who of you have heard of monorepos? Okay, quite a bit. So what a monorepo is like, basically in the first place it sounds pretty strange because what it says is like put all of your stuff into one repo. Usually we had like, this is the backend services repo, and there's a repo for our front end code, and then there's a repo for the next microservice, and so on and so on. And we we have a pretty big microservices infrastructure. And what we did for this project is like we had this one repo containing all of the code. So as you can see from the screenshot in GitHub here, basically, there are just folders for every microservice, and it's all in one repository. And when I, as a front-end engineer, want to get new data, I probably work on like the web client where I want to display the data. Then I probably work on the GraphQL server where I need to implement my mutation. And perhaps I also need to touch the REST API or some of the other services. But I'm responsible for all of these changes and also for deploying them. And yeah, it turned out everybody had a much better grasp of what the system is about and the impact it had. But like it always comes with a downside. So now that everybody was working on every part of the system, we had our front-end engineers working on backends. And if you ask the backend guys, who have like a big experience in building backends, it's not a good idea to like just let the front-end engineers build whatever they want without like thinking about it. And so what we also did is we used a auto-generated backend, and that's what my talk is about, because PostgraphQL basically is a auto-generated backend. So PostgraphQL basically takes a Postgres database and an Express.js node server and creates a GraphQL backend for you. So the idea is a GraphQL schema is created over the reflection of a PostgreSQL schema. So I assume everybody at least at some point has worked with like pretty standard SQL databases. And if you think about it, it's pretty similar to how GraphQL works. You define your data in a graph. You do it in Postgres, and you also do it in GraphQL, because what's an edge in GraphQL, like a person has friends or something like this, is just a foreign key when you're talking in SQL. And PostgraphQL takes this idea. So you define your data graph you have in Postgres, but it goes even further. When I started working with this, I had just like basic experience using MySQL and Postgres databases. But then I realized Postgres is much more than only storing your data, because what you can do in Postgres is not only define your data in your data graph, but also define your business logic in Postgres. And that's a pretty strange idea, and usually when I tell people about this idea, they look at me and think that's super crazy. But what you can do is like you can add triggers, for example, on like if there is an insert mutation on an article, and then you want to trigger push notification. Let's say like an editor is writing an article, and once the article is published, you want to send push notifications. That's like part of your business logic, but you can plug this business logic into your Postgres database. So the database exactly knows when you when it creates an insert statement for inserting an article, and then can trigger push notifications from inside the database. And what also Postgres does is you define your access control in Postgres. Usually you have your layer, your API layer caring about the access control, but it turns out databases have like a pretty big system of controlling access, user accounts, different roles, and so on. So what we also do using PostgraphQL is defining our access control in Postgres. So let's look in how this works. First of all, schema definition. I also already talked a little about this. So that's a pretty basic example. We got articles. An article always has a category, and an article has one or more authors. So that's pretty basic, and that's what your GraphQL schema would look like. And so now we're back at university, and the task is to translate this into a database schema. And basically what it would look like is this. You got your table for articles, a table for categories, and then we got a foreign key here defining one category for each article. And as I said, like an article can have one or more than one authors. We got this table here connecting the authors with the articles. So that's pretty basic what you do in SQL all the time. And so we start layouting our data like this and creating our tables. And so this is what tables could look like. I think that's pretty basic. So that's the article, right? And there's this table that makes the connections to the authors, and then we can link the two authors, Mark and me, as author of this article. And basically, then we're done, and we can just fire up PostgraphQL, which serves our backend. So what we do is we install PostgraphQL, and then we start PostgraphQL. There's this watch command. This watch command is pretty cool because it watches your database schema for changes and then restarts the server, so you can just like work on your database and the GraphQL server is updating itself every time. And boom, we're running. So basically, you only have this one command, which is PostgraphQL. PostgraphQL looks into your database, sees the schema defined in the database, and creates a GraphQL server. It also spins up GraphQL, which basically is the tool you need when you're working with GraphQL. And you fully can use GraphQL and query all the data. So this is a screenshot from the example we've seen. So we got this all articles, which is automatically created. And then you can go to articles authored by articles ID, which is a pretty strange name, but because of this connection, they are auto-generated. They are just named in a standard way. And then we can go from the article to the authors. And then we can query an article and an author. And by now we have written 0 lines of JavaScript code and can have a fully working GraphQL server. We got connections. Connections is a special format defined by Relay. So that's one of the points where Relay is different from GraphQL, or where Relay has some special things it needs in GraphQL. So what connections give you is sorting. A connection basically is a list of things. So what we've seen here, and all articles in this case is a connection. You can see here we can order it by. So this also comes free with PostgraphQL. So you simply can sort it by all of the columns you got in your table. What you also get is filtering by conditions. It creates on your GraphQL server, you can create filter for I only want articles that are from today or something like that. This also comes with relay pagination. For the guys of you who have used GraphQL, there's the special syntax. This is why you have all these edges and nodes, and it helps you to paginate through the data. And you get it for free using PostgraphQL. You also get the mutations auto-generated. So it sees, okay, there's a table called articles. It also generates a mutation called insert article, delete article, update article. So these are all auto-generated for all of the tables. So not only for articles, but also for authors and so on and so on. It's Relay compatible. And you could also write custom mutations if you got like some special cases where you want to, I don't know, like delete all articles from yesterday or whatever. You can just write a custom mutation and then call this custom mutation. So yeah, demo time. I'll show you how this works. So basically, first of all, as I said, we want to create. Can you read it? Yeah.
Yep.
All right. So that's pretty basic SQL. What we are doing here. I've got a Postgres database running. It's completely empty right now. And so at first we are creating this table called articles. It only got an ID and title and a text. So I insert it here, create table, and now the table exists. Then I insert like 2 articles in this table, and they are in the table. So we could just select star from articles, and there are my 2 articles. So nothing special here. But what we are doing now is we are creating, or we are starting Postgres as I've shown before. So I have PostgraphQL watch, and boom, there it is. So we just open this URL in browser. And let's make that a little bigger. Okay, so I think you can read it. So if we look into the documentation here, we can see now there is a query for all articles. I can query a single article. I can query an article by ID, and it's all working. So if I just start writing here, I want all articles, and I want the notes, and then I want the title. And basically that's how it's working. We get all the data here. And we can also query, what else had I think it was called text, and we get the text here. And so that's pretty simple to query the data. We also got the mutations I talked about. So we got a mutation create article, update article, and delete article. They are all auto-generated. And yeah, so that's like our first basic example. What we want to do now is we want to create the authors table. In this example, I don't have this 1-to-n relation, but I would just want to make a simple 1-to-1 relation, so every article has one author. So we create an author table, and I add myself to this table. So now we got this table, and we just go back here, and magically all these mutations appeared, right? That's the watch mode of PostgraphQL. If you look into query, we now also can query all authors. So let's try this. We go for all authors, and we want the notes, and we want the first name and the last name, and boom, we got all those authors that are available in the database. Right now, the only thing that's missing, and that is the connection between the authors and the articles. And so, but that's exactly what we need, because it's called GraphQL, and what GraphQL does is it builds this graph of things. So we do it basically the style SQL would always do it. We create this, we create a foreign key, and then we set all articles to belong to this author. So what I did right now is I added this column to the articles, which says author ID. The author is a foreign key, which references an author, right? So just a simple foreign key in SQL. And now we add all the authors, we update the 2 columns. So now every article in our database has this foreign key linking to the author. And now we can look into, let's go for all articles again. And the notes here. And now we got this field called author by author ID. And that is the field what is basically in SQL terms doing the join, right? It joins the authors to the article. And if we query it right now, we got, let's get the title here again. So we can now query both of the articles again with the author, right? That's pretty cool and super easy. But we could also do it the other way around. So I could go for all authors. We want the notes and the first name. But we also want all articles the author has written. So we can go to articles by author ID, and again, notes, and we want a title. And what I now get is like all articles written by me. yeah, that is all created only by defining your SQL schema. So let's hop back to the documentation, to the presentation here. Yeah. The first question that pops up in the minds is like, we got these mutations, update article, insert article, delete article, and we don't want to make them public, right? Because otherwise everybody would just create articles. So we need some kind of access control. And as I told you, access control is done in Postgres as well. And I show you how it's done because it's pretty easy. That's what you would have in your regular Node.js backend. So in Node.js, you usually at some point, usually at startup of your application, you connect to your database. You connect also to your database using some root because you want to have the privileges to write into your database. So that's how a regular REST API structure would look like. Your client has limited access to the API. Usually you use tokens or whatever you have. But your API server has full access on the database. That's a little different using PostgraphQL. In PostgraphQL, we got this roles defined in database. Roles are basically just users on your database. So I create a role called viewer, and I only grant select on articles to viewer. So the role viewer now can select the articles from the table, but it cannot update, insert, or delete articles. Then I create another role called editor, and I grant all rights to editor on this table, right? So now we got these two roles. One can only select, the other can select, insert, update, delete, and so on. And yeah, so what we are doing with this is our client still has limited access on the API, but the API not has like full access on the database, but the API has scoped access on the database. The access on the database is scoped to one of these roles. If I want to make a request as editor role, what I do is I just send a JWT JSON Web Token. So I send a token, and the token requests the role editor. This token needs to be signed by my backend, and that makes it secure. And then I can use the mutation create article and create articles. But I don't want my regular viewer to have this mutation available. As we defined, the viewer only has select on the database. We can define the default role as viewer. So when my HTTP header is just empty, I default on the role called viewer. And then I still can query all the articles, but the mutations aren't available for me, right? And that's how access control works in PostgraphQL. Yeah, so these are like the two roles, and I can create fine-grained access on this. So for every table, I can define which viewer has what rights. Can it only select? Can it insert, update, and delete on this table? That's pretty cool and pretty easy, and we've still written no line of JavaScript code. And as like Postgres is a database, I don't know, like 30 years old, I assume it's pretty secure in terms of their role management. So if you look into our tables called articles, what we have is a column called status. So an article can have the status published, but it also could be draft, published, or scheduled, or whatever you have. And I want to have my default viewer only to see the published articles. And now it's getting tricky because I granted select on the table for the viewer. The viewer could also select the draft, published, and scheduled articles. But again, Postgres has a pretty neat feature for this, and this is called row-level security. Row-level security basically lets you create policies on the table articles. And what I'm doing here is I create a policy on articles, and for select to viewer, I only want the articles for which this condition here is true. So I only want to have the article's status is published, right? And now I can call all articles as my viewer and only get the articles that are available for this viewer. And as soon as I send my token and I'm authenticated as editor, this policy doesn't apply anymore, and I can query all of the articles. This is how access control works in PostgraphQL and basically Postgres. Yeah, so that's my short overview over PostgraphQL. We now used it in one project which is launching next month, and yeah, I'm pretty excited by what PostgraphQL can do, and we really made a very good experience using it. Yeah, thank you. Any questions? Yeah.
One question. I don't know so much about backend because I'm more expert on the front-end side.
Yeah.
And you say that it's different, the approach, like using PostgraphQL instead of the normal logic between API, and then you have unlimited access to the backend.
Yeah.
So my question is, you talk about the routes that you can define to the database, for example, the viewer route, and what's about the visibility about which kind of object-oriented set can see a different person, a different user, and which way you can approach it with GraphQL.
So I hope I get your question right. So basically here you can specify any condition, right? I'm now checking status equals published, but this could be any kind of condition, and every row in the table that does not fulfill this condition doesn't exist for the role that is called viewer here. And it's like the database really behaves as these articles wouldn't exist. Like if you make select count on it, it just gives you the count of the articles that are published, right?
Just the articles that you can see. Maybe
yeah.
As a viewer, you can see a set, but another viewer can see a different set.
Yeah.
And so something like this filter is made by client, or there is some way to make more sure and make it inside the GraphQL is part of the security.
So this filter lives in the database, right? And the PostgraphQL backend has no way to not apply this filter, because it uses the user called viewer to query the database, and for like the PostgraphQL backend, it looks like the other articles do not exist at all. And yeah, so
yeah, you could parameterize by the user ID.
yeah, so what I'm doing here is like this generic role called viewer, which basically is which is used by all the clients. It does not. So if you have like different users with different access rights, or basically every user has different access rights, you can also do this. It's a little more complicated, but you authenticate with your JWT token here, and what you can do is not only supply the role here, but also supply a user ID here, and then you got this user ID available in your database and can use the user ID also in your policy to limit access.
Thank you.
Yeah, so I think you were next.
Yeah, so I think this is a Postgres question. I don't know. Is there does it go the other way around too? Like the policy that you can say this role can only edit this one field?
Yeah. So basically, what you would do,
like only set publish. Editor may set published, and moderator may set published, and editor only may set draft or so.
Yeah. Basically, what you can do in Postgres is you can define triggers. A trigger is either triggered before or after an action on the database, and this trigger can execute arbitrary code. So basically what you would do in that case is create a trigger that is called before update, and this trigger then checks if you have the
validates
rights to
it.
Yeah.
Second question, if I may.
Yeah, sure.
And the same goes for like normal content management systems have like this notion of somebody creates an article, that's why he owns it or so.
Yeah.
So like, so only that person has access to delete this article.
Yeah.
Because she or he created it?
That's pretty simple because we can do that using a policy. So what we would write then is we want to have for update and delete perhaps. We want to grant to viewer using, and then we want to check if the ID from the article, like the author ID from the article, matches my ID, right? Mm-hmm. So what we would do here is using article.id, article.author equals, and then I get a variable containing my user ID, and only if I am the author of the article, I can delete this article, for example.
Okay. Last question?
Yeah.
This stuff is only Postgres, not MySQL.
It's only Postgres, and yeah, I think it wouldn't be possible in MySQL because it uses a lot of features that are very Postgres specific.
Okay.
Yes, so they're in the back.
Is it possible to filter columns, but not only columns for all the rows, but for specific rows?
Yep. Pretty good question. So I only talked about filtering rows. What you are talking about is like I have a field on the article, for example, which only should be visible to the editor, but not publicly, right?
Yes, this, and also, like for example, we have a list of users, and we have the column bank account.
Yeah, right.
I can see my bank account,
Yeah.
but not of the others. So like column-based permissions, but also with a filter on this one.
Yeah.
Is this possible?
It is possible. It depends a little on what you are doing. So if like you have a users table and you just want to disable the people querying the password hashes, for example, that's pretty basic. And what you would do for cases like this in SQL is just create a view. So you create a view on your table and only grant the access on the view. And the view specifies a subset of the columns that are available for the specific role. But your example is a little more tricky because you basically wanna have to query your own password hash, but not the password hashes of the others, right? You can do that using triggers again, and then like checking IDs and stuff like this. I cannot show it you on stage, but it is possible. We have that in place in our projects, so I can show it to you later, perhaps. Yeah. So again, in the back.
What about migrations? You said you haven't launched yet, but how are you planning to do migrations? And are you planning to do, for example, breaking changes and so on?
Yeah.
Especially with stored procedures and so on.
Yeah. So we traditionally we wrote our applications just as like Node and MongoDB applications, and now we are back to writing migrations, which is like pretty strange. So there are a couple of like projects for managing your migrations, and yes, we are just writing migrations as you would do, like they are. So we got a folder called migrations. There are all our migrations, and on startup day they are executed. So what we have not done yet is like deprecated fields or stuff like this. Usually, and also the website of GraphQL said you would not deprecate any fields. If you have a new field, you would just leave the old there and still be available. But if you need to make breaking changes at some point, I mean, you need to make it, and you need to write in migrations for it. Yeah, so migrations definitely is a thing that is hard to manage. Because like what a problem is we got here. Usually you got all your when you got your business logic written in JavaScript or whatever language you want to use, you got your business logic in one place on Git where you can see what it does, right? And now our business logic lives in Postgres, and there is no single file where I can see where my business logic is, because the business logic is the sum of my schema and all migrations that are applied to the schema, which makes it a little harder to maintain, but for our project right now, the business logic comes down to, let's say, 100 lines of SQL statements, so it's not that big, and it works for our case. But yeah, I'm not super happy with that, and but I don't think there is any better way to do this, because like we are not the first people using SQL, and yeah.
My question is, you said you implement your business logic in the database.
Yeah.
how do you test your business logic? So how do you can guarantee that you do not break your existing business logic when you implement new features?
Yeah, so the only thing we are doing right now is testing the outcome, right? So we don't have a way to like write unit tests on our SQL functions. What we do is like we have a lot of GraphQL queries which expect a result, having like snapshot testing, and then we can look if the outcome still works. But yeah, so there is not what you would have in unit testing for JavaScript, for example. So I think you had a question, right?
Yeah, so authentication then is kind of external to the system, or at least in the example that you presented, where you authenticate to some system which gives you a JWT token. And then basically you, like once authenticated, the database can authorize based on policies or preferred.
Yeah, right. So we got another system outside of PostgraphQL which generates these JWT tokens and signs them. And then PostgraphQL also gets a secret that the JWT uses and verifies the JWT. But there is this other instance which issues the token.
Is that standard software? Is it hand-rolled?
That's standard software. There are like a lot of libraries out there for creating JWTs. In our case, it talks to our Active Directory, but there are like connectors to basically every kind of authentication. So again, in the back.
Is it possible to like compose or inherit between rows? Like have a user and then a user with a specific ID for special access rights?
I don't think so. There are some things you usually have in your database, like as you said, like there's this user, and then we got this special user, which I don't know has a second, first name, whatever you have, and what you always end up doing using SQL is either have another table having this special data, or you have a lot of empty columns. I have not found a perfect way around this, and it always depends on what your data looks like, but that's basically what we are doing. Yeah, so you don't have inheritance or something like this.
Okay, so you can't like put two rows into one query, authenticate as like two rows for one database query? I'm not sure if I got it correctly. Like, for example, I'm a user and I have a specific ID. Like instead of, for example, if you have to change the user permissions, cut them down somehow, or expand them, instead of having to go through like all users, updating each row, they can just say like all users have this permission, and like a user with a specific ID can select the extra data or so, something like that.
Yeah, what you can do basically, and I left this part out, but what you can do is computer properties. Computer properties basically are properties which have a stored procedure. This is what a function is called in Postgres behind them to resolve them. So that's a pretty basic example, but you could also apply to the question you just asked. Is we got an article, and this article has an ID, and then we got a share URL, and this share URL basically only has the ID here, and this part is always the same, right? So I don't want to store the share URL in the database, and what I do then is like create a computed property. It looks like this. I say like article share URL, and it basically takes the string and appends the ID of it, and that's like super simple. But basically, you can have very complex operations in here and create your own custom queries that like do whatever you want. Well, I think you were next, right?
I have a question regarding the monorepo.
Yeah, yeah. I love monorepos.
What was the biggest pain point with a monorepo working in a team regarding merges or rebases or?
So when we started this project, the biggest pain point was we started this project not having a monorepo, and at some point we decided to migrate using a monorepo. But we wanted to port all of our commit history to this monorepo, and this was pretty much a lot of rewriting Git history, which was pretty painful. But after we've accomplished that, right now when we have this monorepo, I really can't think of a thing that is worse than having it in separate repos. Because what I really like about is I can ship a feature as a single branch, and this feature got all it needs, right? So this branch has the modifications on the back end as well as on the front end. So what it does is it makes us way more thinking like feature centric and not like service centric.
Do you have some commit policies? One commit applies to the backend, one commit applies to the front end, and one commit applies to the, I don't know, connection service?
We don't have strict policies on that, but usually, yeah, it works like it's like as a developer, you first write your backend usually, and then you write your front end. But we don't have strict policies on this. So from time to time, it happens that there is only one commit changing backend and front end at the same time, and there is only this one commit. Yeah, so this happens, but I don't think that's a big problem, because if this commit just like broke something, you roll back this commit and you roll back the changes in your backend and your front end, which is pretty cool. So I don't know how much time we've left for questions. Tim, let me know.
Yes, I think it's
like
5 minutes.
Okay, so I'm happy to answer all of the questions, but I don't want to take the time from the speaker after me and from the break. So who was next? Yeah, go for it.
I actually have a question about how the connection to the database is happening from Postgres GraphQL.
Yeah.
Like, are we actually connecting using the user we acquire from this token?
No. So the connection, you define a username and a password or whatever you have, which is used for the connection. But then there's this feature called set role, and then you can scope yourself to a lower role, basically. So what it does is Postgres also connects with the username and password it was supplied, but once a request is made as viewer and you have limited access, then at first the command called set role viewer is executed, and then after that all queries that could be made on the database are scoped to this single user, and after that, so basically the scope is set for every access. So yeah, there is still this connection open which has basically full access, but the requests which are made are scoped to the role of the user. So yeah, go for it.
Do you have some kind of rate limiting? Because like one thing I think people think when they see GraphQL is,
yeah,
it needs to take a lot of.
And then there are the site reliability engineers and start talking about caching, and so we don't have rate limiting, and what we do have is caching. So, but usually when you talk about caching, you talk about HTTP caching, which sits between your API and the client, right? So that the request does not hit your backend, but hits your varnish or whatever you have, and varnish answers your GraphQL question or your GraphQL request, right? That's not really possible with GraphQL because every GraphQL request looks different. Because like what we are doing, for example, the client requests images in exactly the size of the client. So basically, and all of GraphQL requests are post requests, so you can't really cache them. But where we implemented caching is between the database and PostGraphQL. So there are a couple of different places where you can implement caching that not every request hits your database. There's this repo called Data Loader from Facebook, and what Data Loader does is basically caches in this layer between API and database. So it tries to minimize requests against your database. Also, there is caching in Postgres that if there is a complex call on your database. The database does not need to recompute it every time this complex request is made. So our project here isn't launched yet, but we made some load tests and it works out pretty good. So we don't really need caching between the client and our API layer because we are able to just spin up more API client or API layer service, right? So this server where PostgraphQL is running, so we are able to just spin up more and more of these. And then the harder part is to make it performant using when it comes to your database, because like there's this one single database that's behind all of these requests. So this is where it gets critical, and this is where data loader, for example, comes into place. Yeah, so...
Do you have any experience the way around, so that you invalidate your cache at the client side, so you can subscribe for changes on the database?
So this question has a couple of different aspects. So there's one thing, like there are GraphQL subscriptions is one part of the question. There is a suggestion for GraphQL where you can subscribe to changes on data. This is pretty cool, but I have not really seen a working implementation of this, and also PostgraphQL does not implement GraphQL subscriptions right now, but it's a pretty cool feature if you just get like opening up WebSocket and get the data once it changes. But what you can do, and what we are actually doing, is create these listeners on the database. And a listener could be triggered by any action on the database. And what this listener does is it gives us a callback into our node code, for example, and then we can do whatever we want. That's how push notifications work. So we got this trigger in the database for changes on the articles, and then this gives us the callback in our node code from where we send our push notifications, for example.
But it's, to the clients, it's outside the scope.
Yes. So, but you could use this technique we are using for push notifications for like super simple subscriptions to the client, right? Because we just get a callback in our node code, and then we could open WebSockets from our node code to our website and just simply reload or whatever you want to do. Yeah. So yeah.
Last question.
Yeah.
You can connect GraphQL to any kind of database. This is clear.
Yeah.
You can connect also to another API service, for example.
Yes.
You can do it through GraphQL. You try it and
so you can do it in GraphQL. This does not mean you can do it in PostgraphQL, right? We've done this in GraphQL. For example, what we have is like we have a proxy layer which basically aggregates different microservices. So the clients are hitting the proxy layer using GraphQL, and then GraphQL distributes these queries to different services using just simple REST APIs behind them. So the client asks our proxy layer, and then we decide, okay, this needs to be answered by Elasticsearch, and this needs to be answered by the Twitter API or whatever you have. So that's what we are using. It's working, but it's getting pretty complicated if you have like complicated graph data. So for example, if you resolve some data from Elasticsearch, let's say, and then for every result from Elasticsearch, you need to hit the Twitter API again or whatever you have. That's pretty complicated. And so basically what we are doing there is every GraphQL request is represented by an AST abstract syntax tree, and in our proxy layer we are taking this abstract syntax tree and try to like split it into the different services where they need to be answered, and then collect all the answers and rebuild this syntax tree and then resolve it. But that's pretty complicated, and I wouldn't say that's a good idea to make it that way, but it's working. All right.